I would like to welcome everyone on behalf of the McGill Alumni Association of Turkey for this evening's event, Meet the Experts, COVID-19 Variants and Vaccines. This evening we are joined by two esteemed speakers who are experts in the field of infectious diseases, clinical microbiology, and immunology. So our first speaker is Professor Dr. Önder Ergönül, who's a graduate of Hacettepe School of Medicine in Turkey, and he also has a Master of Public Health from Harvard School of Public Health. He's one of the world's leading experts on Crimean-Congo hemorrhagic fever, and in 2020, he became one of Lancet COVID-19 Commission experts on vaccine and therapeutics. And he's a director of Koch Center for Infectious Diseases, Koch University. And between 2018 and 2022, he's been serving as an executive committee member of European Society of Clinical Microbiology and Infectious Diseases. And he's also a co-principal investigator of the International Ethics Joint Project at Harvard School of Medicine and Koch University School of Medicine. So Professor Ergönül, the floor is yours.
Thank you very much, Urgul. And I would like to share some slides, if it's possible. Can you make me co-host? And I would like to salute all the participants, the McGill Alumni Association. I know how important it is from the Harvard Alumni Association. That kind of meetings are very important. So I would like to summarize actually what is the situation for COVID-19, some major problems, what we have learned and what will happen for the future. Then I will forward my talk to Dr. Issa from Jordan. First of all, I should say we maybe have all learned that there are phases of the disease. There are different phases. At the first phase, that means usually the first week of the disease, the viral reproduction is very important. And in this level, you can use some antivirals. Up to now, we have tried many antivirals. There were repurposed drugs from the beginning of the 2020, but almost all of them didn't work well. There is no perfect drug up to now, and there are some alternatives, of course. The recent one, just last week, it was announced that molnupiravir could be a good choice, and many countries now waiting for that at the waiting list for molnupiravir, especially for the oral choice before the hospitalization. But if this period goes well, that means the first week of the illness, that's fine. And many of the patients stay in that level. But sometimes a certain percentage of the patients, let's say 10% of them, may get worse, could be hospitalized. And among the patients who have been hospitalized, some of them, again, maybe 20%, could go to the ICU, intensive care unit, and could be intubated. And overall, the fatality rate is about 3 to 5% in the world. So that's a fatal disease. So in each level, the therapeutics can change. At the first week, we can talk about the antivirals, but at the second week, it is more a immunologic response of the host. Therefore, more immunologic mechanisms are active, and we may use some anti-inflammatory drugs like tocilizumab, corticosteroids, etc. So one important question is, what was the effort of the world? This is important to get some lessons for the future. While we are considering the success rate or the response effort of the whole world, we can talk about the number of new cases and the case fatality rates. There are lots of different parameters. And in fact, at the beginning of the pandemic, people tried to compare the efforts of different countries. But now I can say that you cannot do that. We are not able to do that. We cannot say that one country is much more successful than the other. Unfortunately, we cannot say this. It was more easier before the pandemic era. This pandemic changed all our understanding, because it depends on the population of that country, income, education, okay, but it cannot explain everything. Also the capacity of healthcare workers, their resilience of the people. But more important thing is using data was very important. Some countries did this very well. Using their own data and learning from their data and to look forward was an important feature that we should improve in all over the world. And in terms of treatment, we are still fighting to find the better alternatives. In terms of vaccination, yes, we had some success. At least this is maybe the most successful era, providing vaccines much faster than we expected. And still, we are using the public health measures. At the beginning, there were lots of discussions and debates about the public health measures. If you compare the risk factors between different countries, what we can say, obesity in terms of individual risk factors turn out to be the most significant one among all the others, like hypertension, diabetes, etc. If you collect all these risk factors, obesity comes number one. And then the healthcare capacity of one country was important to have lower case fatality rate. If you think that case fatality rate is an important measure, yes, it is an important measure for to get an idea about the extent of the outbreak. But in fact, what we have learned in terms of information technology, still we are converting data to information, and then from information to knowledge, and then we are trying to get a wisdom all out of these years, all out of this process. But it should be much faster than we expected. And then we defined all this process as warp operation or light speed operation, etc. These are the words that we owned from the past known operations. It should be very fast in order to produce knowledge. But while we are doing this fast knowledge generation, sometimes some of our colleagues did hawkish interventionism. That means trying to use a lot of intervention in order to get a necessary result. On the other hand, just opposite to this, sometimes some of us did medical nihilism as a philosophical term. That means people didn't take care about what's going on coming to the therapeutics or the vaccination, especially in vaccination. Even now we can see anti-vaccine campaigns and up to the anti-science campaigns. So among these, to produce sensible medicine, this will be a new concept that we are going to use after the pandemic. This is one of the things that we should learn, in fact, collectively at the global perspective. So also we have seen the fight of the expertise and confidence. Sometimes some people had a higher confidence, although they didn't have any expertise on that topic. This came out to be in terms of vaccination debates. In terms of vaccinations, there were some criticisms about the vaccinations, or misinformation, I should say. There were lots of the literature and paper trying to explain the weak parts of these anti-vaccine campaigns, etc. We tried to convince the people to get vaccinated. Most of the time, it was a basic mathematical problem, actually. Most of the time, people misinformed the others, some people, about the vaccines. But in fact, among the vaccinated people, how many of them got infection compared to among the not vaccinated people having infection? This was the equation. In fact, this is what we know from public health classes, relative risk. So by using the relative risk of unvaccinated compared to vaccinated one would give the importance of the vaccination for us. Still, vaccination is the most important parameter to get protected from the pandemic. And just to tell about the importance of vaccination, I would like to use the seatbelt analogy. In fact, the seatbelt, using the seatbelt is not 100% guarantee against the traffic accidents. Still, you may have the traffic accidents and you may die. I mean, if you are using the seatbelt, but seatbelt reduces the risk. This was very important. So reduction of the risk or risk reduction was the concept sometimes difficult to tell about. And in vaccination, again, just like the seatbelts, we reduce the risk of having disease and then consequently death. So, but we cannot give the guarantee not to have a disease or not to die. This is a useful analogy that I used sometimes in also social media or in media. And besides the vaccination, we should continue with the public health measures, which is, again, maybe some of us get bored of listening about using mask, social distance, hygiene, etc. These are the public health measures, plus vaccination and vaccine coverage. We should still do both of them together at this level. But don't forget that only rich countries or high-income countries with upper or high income have greater advantage compared to the other part of the world. The lower income countries have very low level of the coverage for vaccination, about 1 to 2%. There are some countries, the whole vaccine coverage is about 3%, maybe less than 5%, but we are talking about more than 60%, 70%, and we are comparing all these upper or higher income countries among themselves. We shouldn't forget about the world itself. So one thing, coming to the end of my talk, one important thing is, okay, this pandemic will end. We can say that easily. We can say that we came to the point with different variants, with some vaccination production or therapeutic production. In any way, we came to a good point. I mean, still we have some cases, still deaths, but we are much more safer compared to 1 year ago. So it will be much better, I believe, especially next year, it will be much better. But the problem may continue in any way. This disease will become like an endemic one. So it just like influenza, even more, we may suddenly see in the next years that virus again, causing a pandemic. Just to remind you, H1N1 influenza virus first did a great pandemic in 1918, it's called the Spanish flu. Then for a while, we haven't seen any case of H1N1. We have seen mutated cases of H1N1 and some variants, of course. But then in 2009, almost 90 years after this first pandemic, we have seen again the second pandemic of H1N1. So where did this virus come from? I mean, there were other mutations of the H1N1, but this one, this H1N1 was stored in the nature. This is what we think at the moment. So stored in the, how can be stored in the nature? In the animals, among the animal reservoir, then as a zoonotic disease, it appeared again in 2009. So this probably will happen like this in this disease. But meanwhile, we have to collaborate. We have to work together. That we have good examples from the past, from our history. Let's say in polio vaccination, for instance, in the Cold Wars, during the Cold War between the United States and USSR, the scientists came together and they performed a great action. And they performed a wonderful collaboration against the polio. And they developed the polio vaccination, used them both in the United States and Soviet regime, and they succeeded. So this was a good example that we should remember for the future. Thank you very much for your patience. Then we will continue with some questions with my colleague Issa.
Thank you, Önder Hocam. So now we will proceed with our second speaker's talk, Dr. Issa Abu-Dayyeh. who is a McGill graduate. He received his PhD from McGill University in Microbiology and Immunology in 2009. And he later started his research career in cancer immunology at the University of Oxford in the UK. And he's currently the head of Immunology and Research Departments at Biolab Diagnostic Laboratories in Jordan, and also the head of COVID-19 genomic characterization and surveillance program at Biolab Diagnostic Laboratories, and works in collaboration with NIH Centers for Research in Emerging Infectious Diseases. So Issa, the floor is yours.
Thank you very much, Ur, for arranging this beautiful event. Thank you for having us connect with all our McGillian graduates. This is the first event that the Jordanian chapter collaborates directly with another chapter. So we're very glad, and huge regard from all Jordanian people to the beautiful Turkish people that are with us today. Also, it's a great pleasure to give this event with Professor Önder, who is a very well-respected figure in the field. I really enjoyed his brief talk. I think I will build on that a little bit. This is the times where I think countries have to come together. You've put graduates of McGill together, but you've also put scientists from different countries together. And I think COVID-19 was one of those diseases that have proven to all of us that infectious diseases and infectious organisms don't know any borders, right? And they jump from country to another, and as long as they find a host that they can enter, they will go in. And that's why we learned that we really need to work together and collaborate together, not only to stop polio, like Professor Önder said, but also to confront any emerging infectious disease. Here in Jordan, basically, I will share with you today two things. I'll build a little bit on the vaccine stories, talk to you a bit more about the types of vaccines that are available at the moment and how they briefly work, so we can set floor for some questions later. And also we'll talk about our efforts in Jordan, and particularly my lab's efforts to establish genomic characterization and surveillance center for COVID variants. So this is, just briefly here, a schematic of the different platforms that are used for vaccines. Some of them have not released their vaccines officially yet for use. They're still in different phases of trials, and some of them have already been out there. This is here a schematic of the SARS-CoV-2 virus, which is an RNA virus. And you can see this, this spike here on the surface of this virus, which we actually call the spike protein, or the S protein. And this has been one of the major targets for many of the companies that produced vaccines. Not all of them, some of them use the full virus, but a lot of those use actually this protein, because this is the protein that is mainly involved in binding to our cells and helping the virus to get in. So I'll just talk about the ones that are in the market to just, build some floor. One of the methods that have been used is actually one of the traditional methods used in many other vaccines, was inactivated vaccines. And what that is technically isolating a virus, SARS-CoV-2 virus, and then growing it in cell culture and getting more and more of that virus, and then finally killing it or inactivating it using certain chemicals and injecting that into a patient. This is, for example, the type of strategy that was used in the Sinopharm, the Chinese Sinopharm and Sinovac vaccines. Sinopharm that has been used widely in Jordan. Probably around more than 50% of people in Jordan who have been vaccinated received that vaccine. And just to give an idea for attendance, Jordan is around 10 million people. We have reached around 45% vaccinated with or 50% with one dose. I think 40 or 45 with two doses, and half of those have received the Sinopharm vaccine. In Turkey, I understood from a brief conversation, Dr. Önder, that it's Sinovac that has been used in terms of that strategy. Now, another platform is replication incompetent vector vaccines. what do we mean by that? It means we're actually bringing a virus that's different than SARS-CoV-2. So it's not a COVID virus, right? It can be an adenovirus usually, or any other virus. We empty it of its content. So this virus is no longer able to infect people or replicate or divide. So it's just being used as a carrier, as a Trojan horse, if you wish. And inside that, we place in basically a piece of DNA that includes the gene for spike protein. You know, sometimes it's modified a little bit, sometimes it's not. But anyway, what that does is when we inject that, and by the way, this is similar to what we see in vaccines like the AstraZeneca, University of Oxford vaccine, and the Sputnik, the Russian Sputnik vaccine. So what it does is this virus is used as a carrier, it's injected, it finds its way into cells because it's good at it, it knows how to enter a cell, it releases its gene contents, and then your cell will use that gene to produce spike protein, which your immune system will recognize, produce an immune response against, and then technically make you vaccinated. Third platform that is being used here is RNA vaccines. And this was, you know, quite a revolutionary method or platform. It's been used previously. It's not like it has been invented from scratch, but it has been used in limited contexts. And the COVID-19 crisis created a huge opportunity for funding and support for this platform, because it could be a quick platform. This is a platform where you can basically get any code you want, just print it out like you print a, you know, a letter on a printer. Just, you know, you get, you know, the letters, you print them out, and then you produce that piece of RNA. So, you know, DNA is the initial, you know, genetic material. From that, you get an RNA, which is like, you know, a page. It's like a script of that main book, like, you know, a recipe that you can use to produce the spike. So this is the piece of RNA. It's usually put inside a molecule, a fat molecule, to protect it. And that's what gets injected into the body. This RNA finds itself into your cells, and inside your cells are going to be tricked. Oh, they see a recipe that they can execute, so they will just produce whatever it codes for. And in this case, it will be the spike protein again. And that will induce your immune system to produce an immune response that will hopefully protect you if the real virus comes in and tries to infect you, either protect you from getting infected or protect you from having very severe disease. So briefly, these are the three platforms I wanted to talk about. Obviously, as you can see, there are many other platforms. Some will use, instead of RNA, they will use DNA vaccines. Some will use replication competent vectors, so a vector that can actually divide inside of your cells, and some can use the actual protein, you know, like a recombinant protein, like Novavax, etc. So I'm happy to answer any questions that you might have regarding the different platforms and how they work. Another small point I wanted to make here as an immunologist is how do things in terms of immune responses work, you know, in a natural infection and versus vaccination, and how does the mode of vaccination affect that? I received a question, I believe yesterday or before yesterday. I don't know if the person that sent it to me by email is attending today or not, but that was one of the questions he raised: is which is better, a natural infection or, you know, or a vaccine? And obviously you can see that it's not exactly the same way you're receiving the virus. In a natural infection, you're receiving it through your mucosal membranes, whether it's going in through your nose or mouth or even, you know, or your eyes. And then that virus is able to really mount a very vast immune response, because obviously the full virus, the active virus is going in, your immune cell is seeing every single bit of it and trying to mount a response against it. So you can see that we have a lower respiratory tract protection here in the lungs, as you see in green, and also you develop an upper respiratory tract protection in blue. And these are different antibodies that do the job. Usually with the lower respiratory tract, it's an antibody of a subclass we call IgG, while in the upper respiratory and mucosal membranes, it's an IgA. So we've got both happening. So that's really good. But at the same time, we'll talk about the risks of getting such an immunity in such a way. Now, if we look at intramuscular or intradermal vaccination, and this is what we've been receiving, right? I mean, for all of those of you who've received the vaccine, they've all received it in the arm and the deltoid here. So you can see that mainly this mode of vaccination will induce an IgG response. So rather a lower respiratory tract protection. So that will really protect you from having severe inflammation in your lungs and from getting into a crisis. However, as you can see, the upper respiratory tract protection is lacking, and that's problematic, because that does suggest that you could actually harbor the virus in your upper respiratory tract. You could have it in there, maybe not feel anything, but then again, you can transmit the virus to other people who are unprotected. So that's a little bit, has been quite a story, and it was quite a dilemma and debate among all the different vaccines that are in the market. Now, interestingly, intranasal vaccinations, which has not been in the market yet, but my prediction as an immunologist is that this is eventually where the future will go, really, try and introduce that virus through the nasal cavity. And what that will do is that will mimic more natural infection and therefore induce both IgG and IgA, upper and lower respiratory tract protection. So far, we don't have those in the market. Some vaccine platforms are not even compatible with this mode. For example, heat-killed viruses cannot be delivered in that way, right? But for example, vector-borne vaccines like AstraZeneca and Sputnik can, and that's something I believe will happen sooner rather than later. RNA vaccines is still I think debatable whether they can introduce them this way or not. Just to talk a little bit in that final bit about what we've been doing in terms of surveillance. Dr. Önder mentioned something very important. This pandemic has taught us to try and use our data. And those countries that have managed to use their data really had the upper hand, had the advantage of being able to act upon it and protect its people more. But sometimes before you use the data, you need to generate that data. And I think sometimes we forget how difficult it is for certain parts of the world to be able to generate that local data in order to use it. So that was one of the things we were concerned about. I mean, Jordan, in terms of capacity for next generation sequencing and understanding the genetic code of the virus and understanding the lineages that are out there, the variants that are there, we did not have that happening on regular basis and in a good capacity. So that was a bit problematic. And this is where Biolab and my lab has been working very hard in the last year and a half to achieve. Just to take you through a small timeline. So here's December 2019, the emergence of the first reported case of COVID-19 in Wuhan, China. Right during that time, it was starting to spread in Southeast Asia, and this is where we realized this is coming. This is serious, and this is spreading. And in fact, the first case of COVID-19 was reported in Jordan on the 2nd of March. And that is a few months after it appeared in China. And 2 weeks later, we were able to isolate the first case of COVID-19 in Biolab, in-house. So it was started to be detected in our labs by PCR. And this is where I started establishing contact with Professor Christian Anderson in the United States at the Scripps Institute in San Diego, proposing to him that we send him some samples from Jordan to sequence and look into the contents of that virus and try and understand what's happening. In fact, 2 days later, the state of emergency was declared nationally in Jordan, and we all went into a total lockdown during that time for probably a month and a half or two, where everyone was actually home. During that time, sequencing was taking place, and the first COVID-19 sequence from Jordan was published jointly with the Scripps Institute in the beginning of April 2020. And that was followed by us sending more and more samples to the US. So between April 2020 and around end of January or February 2021, we managed to jointly sequence 579 viruses, of which one main important finding was us discovering the first case of the UK strain B117, now known as the Alpha strain. So that was all good and nice, but we were all thinking, right, we're sending the samples to the US, but we've got NGS machines in our lab, and we need to get those running. We need to get that technology kicking and to produce our own data. And that's why we started doing some trials in our lab where we have started to compare our results with the scripts, and we managed to actually start being able to sequence viruses in our lab. And then during that time, between February and May, we managed to publish from in-house 39 sequences. And those were important sequences because we used different strategies that enabled us to report the first P1 and B1351. So B1351, it was what was known as the South African variant or beta variant. P1 was known as the Brazilian variant or the gamma variant. And then later on, the 617.1 and 617.2, the Indian variants, which are known now as the Delta variants, which are, the prominent variants in Jordan and I believe in Turkey as well. So we were able to be really the first warning spot for the authorities and many other people to start and, use this information to take more active decisions in terms of protection, in terms of which vaccines to employ, et cetera, et cetera. And then we decided to maintain those efforts, and we decided we wanted to build capacity and be consistent. So we applied for an award at the Centers for Research of Emerging Infectious Diseases in May. 36 different applications competed, 6 of them won, and we managed to get that. And since that time till now, we've put on GISAID, which is the global, the global initiative to share influenza data, the global platform, 91 sequences, and we have a total of 793 sequences from Jordan on that platform now. The aims of this award were 2 main ones: to develop a SARS-CoV-2 surveillance system in Jordan, and that's what we've been trying to do. And the second important aim is to develop a training platform for in-country NGS capacity. We want our scientists to be able to do it themselves and to be able to inspect that data, analyze it, fix any changes that need to be fixed, and put that data out there for all the scientists in the world to benefit from. And we produce also trees like those ones you see here. We call them maximum likelihood phylogenetic trees, where we can explain what are the different families of the viruses that are found in the country and how they're evolving with time. Finally, I'd like to also acknowledge a big team that's working on this in Jordan from Biolab, a team from Thermo Fisher that's also helping us a lot in the technical aspects, and also a big team from the Anderson lab from the US who's been contributing a lot to our work. And I'll be happy to take any questions regarding other 2 topics. Thank you very much.
Thank you, Issa. If you could maybe stop sharing your screen.
Sure.
Okay, perfect. So we have received some questions in the chat box during your talks. And Sevi would like to know, this is a question for Professor Ergönül. So according to your expertise and foresight, when would the world will throw and get rid of the masks forever, just like graduates throwing their mortarboards?
Thank you for that question. Always our, the things or thoughts for the future were wishful thinking. In fact, we're all optimistic at the past. If you look at the history of the pandemic, I mean, that means 2 years. But now the scientific environment almost have a consensus that we can get rid of the masks at the end of the spring of 2022. So we have at least 6 months, I can say. Definitely, this is for sure that, especially for the northern hemisphere of the world, we will definitely use these masks in the winter. I mean, for sure. That means 6 months, also including the first months of the spring 2022. So therefore, hopefully, we will get rid of, end of the spring, the next spring, and the starting of the summer.
So here's another question from Keith. Based on the characteristics of the COVID-19 genome, is it an eventuality that an even more virulent strain emerges in the future? Does the probability of this rise each year that the virus is with us?
Of course, there's always a risk of having more harmful or more dangerous or more risky variants to have. But in fact, we should be very careful about the first reports for the news, especially, because all first news may become biased because of the epidemiological reasons. For instance, one of the first Indian strain variants, when it came first, the fatality rate was much higher. But in fact, the geography of that variant emerged, the fatality rate was high. So therefore, such biases are always happen. But now, up to now, we cannot say any kind of variant is more lethal or more fatal than the other one. We cannot say any such conclusion up to now. This was taught at the beginning for Delta variant, but now we all agree that Delta variant is not significantly much fatal than the other ones. So these were all based on small sample sized papers or study results, especially done by the ambitious and enthusiastic scientists. So therefore, we should be very careful and, in a cool way, listen for some concluding results.
If there is anyone else who would like to ask a question, they can just raise their hands. And in the meantime, I have a question. So I would like to learn a little more about the MAC and Ridgeback antiviral that's being developed. So like if you could give us a little bit of information about that and whether a therapeutic will actually become available in the near future. And if it becomes available, will the course of the disease change dramatically?
Yeah, among these antivirals, up to now, as you know, remdesivir was known to be useful and in terms of the reducing the fatality rate. In fact, it was a little bit, depending on some conditions, still useful, I believe, in remdesivir, but it is intravenous. For the molnupiravir, as you said, produced by the MSD, Merck Sharp and Dohme company, it is oral because if the disease is mild or moderate, using oral drug is much better because they will be followed up at home. At home, using intravenous IV drug is much more difficult compared than using in hospital. So this is promising. According to the first results, in terms of the reducing the fatality and or hospitalization rate, it is successful. All the scientific environment accept this, but we are not sure about the cost is about $700 per cure per person. Therefore, this is not this is an important money for many of the people in different countries. But in that condition, the pharmaceutical companies can produce the cheaper alternatives. But in which countries? For instance, Turkey is in between. There were cheaper products for remdesivir produced by Gilead, but one course was about $3,000 in Turkey. In US, also in Turkey. But in Turkey, there was no cheaper form. But they produced cheaper form in some countries, more lower and middle income countries, even lower income countries, not even middle. I hopefully Merck has already learned from this experience and they will make the cheaper forms, but I don't think for Turkey.
There is another question from Professor Lucian Feist-Schenojak, and it's about architecture.
Oh, okay.
So she's asking, do you think that the COVID-19 pandemic and the prospect of future pandemics has already or will change the architectural design and allocation of space in hospitals?
Definitely. I definitely believe that the architecture structure, there are lots of lessons that we learned from that we should have learned from the pandemic. And hopefully we should come together and having these senses or our thoughts fresh, that we can get some common conclusions together with architects and professionals who lived in this tragedy. I believe, for instance, at the beginning, I should say, we should have opening windows, for instance. This is very important, and ventilation. And the square meters and the number of the people per square meter was very important Of course, especially in big cities, metropolitan cities like Istanbul, the space is the major problem. I mean, but of course, we understood that the bigger or larger hospitals having more spaces, if you think about sanatoriums, for instance, their ceilings were tall. So they did something, they learned something, you know, this increased the volume, the metric cube of the air in one room is much higher in classical sanatoriums, that these are historical sanatoriums now. But our hospitals are much smaller, you know, in a lower space, etc. There are lots of things to learn, and we should, hopefully we can make a workshop or something and get our feelings and ideas.
Thank you for that. So again, as I said before, if you want to ask your questions directly, you can just raise your hand and ask. I want to also get Issa's opinions on the obesity and how it contributes to morbidity and mortality in COVID-19.
I think the lipid meta. Did you ask this to Issa or both?
It's
Issa
for both
also,
of you. It's for both of you, but you mentioned it in your slides, so I just wanted to have his opinion as well as an immunologist.
Yeah.
And obesity is also a pandemic, right? And we can't even talk about that.
Yeah. No, thank you for the question. If I'll comment briefly, and I will ask a question to Professor Önder, because I noticed he's published one of the main findings of one of his publications was that obesity was the most important factor. Yeah, I mean, from an immunology perspective, you know, having fat cells and, you know, creates a very special environment in terms of changing the behavior of immune cells. So you find the monocytes and macrophages in the tissues becoming very pro-inflammatories. They, you know, they really promote inflammation. Even, you know, the other immune cells also go towards increasing the inflammatory process. And that environment really makes it very dangerous for the patient as he progresses through COVID, because that makes him more prone to severe symptoms. So, you know, in addition to hypoxia, low oxygen levels, etc. So there's a whole bunch of, you know, I don't want to go into the details, but in fact, you know, having that those fat cells will have a strong impact on the immune system, producing that pro-inflammatory environment. Now, my question to Professor Önder on that is, I've been reading some papers about this, and there was a high impact paper actually that reported that patients that were overweight were more protected than normal patients, but obese patients were at high risk. So there seems to be some controversy in the literature about the role of BMI and how higher this BMI is in the outcome of disease. How could you comment on that?
Okay, thank you very much, Issa. So this is one of the things that we are also interested in, both epidemiological level, ecological data, but also in laboratory level. In fact, just thinking about the coagulation, inflammation, and also obesity, they are all like have some common pathways. So this is very important, and it will be very important for the future of the medicine. So that means obesity is a sort of inflammation. And we have inflammation in COVID-19. So, of course, the level of the obesity is very important. I mean, the morbid obesity, that means the extreme obesity, is the most important parameter. Sometimes you cannot show the overweight, the impact of overweight on the COVID-19 fatality. We couldn't show this, for instance. But if there is a higher prevalence of the extreme obesity, then the case fatality rate was much higher in that countries, for instance. What we have done, it was the ecological data analysis, like comparing countries according to the obesity percentage. Of course, there are some limitations while doing this because of the lack of some healthy data. But on the other hand, at the laboratory level, we also work this in our laboratory, and the fatty acids or the fat metabolism is very important, driving the inflammation. So definitely the fat metabolism also increased, and there is change in the fat metabolism in COVID-19 infection. So I'm sure there will be much, important, significant studies coming out. We will see in next even few months or maybe later. So we will be able to explain the relation between the infection, inflammation, and obesity.
Thank you. So I also want to ask about other prevalent infections and also like emerging infections. And since all the resources are being, put into COVID-19 research right now, how does it affect other infections which are very prevalent, especially in our geography, like Crimean-Congo hemorrhagic fever?
Yeah, I mean, to me, Ergönül, it is, Crimean-Congo hemorrhagic fever was the most important one that I was dealing, but of course, you cannot compare with the devastation that COVID-19 did. So impact of COVID-19 is much higher than Crimean-Congo hemorrhagic fever. Turkey has the highest number of the cases in the world for Crimean-Congo hemorrhagic fever. There is a relation between Crimea and Congo. So the migrating birds were carrying the ticks from Crimea to Congo, to the Africa, in fact. So then the Turkey or such countries were the stopping regions for the migrating birds. So we still, for instance, every year we have about nearly 1,500 cases with 10% fatality, but this makes only 150 deaths. But in Turkey right now, in every day, we have more than 150 deaths because of COVID-19. So the impact, relative impact is important. I mean, at the moment, still there is an Crimean-Congo hemorrhagic fever diseases in Turkey significantly, but compared to COVID-19, the number is much less. Therefore, we couldn't increase the impact of that disease, but learning about COVID-19 will be translated to COVID-19, to Ebola as well. I mean, in 2014, there was a huge Ebola outbreak in Africa, in West Africa. So I'm sure that we will translate the information or knowledge that we learned from COVID-19 for Ebola and Crimean-Congo, etc.
So it will have a positive effect.
Yeah. Or if I may add a word of caution here that actually you raised, and I think it's a very important point to keep in mind, is because the world has understandably put so much energy and focus on COVID-19, many laboratories that used to screen for other infectious diseases stopped doing that or are doing that minimally so that their resources could be transferred to screening for COVID. So that's very important. And we're seeing that in Jordan and many low to middle income countries where patients that are trying to get diagnosed for diseases like hepatitis B and hepatitis C are not being able to be screened as efficiently and as quickly as they used to before COVID times, because most of the resources are being pushed into COVID screening. And what that means is that I expect that in many other infectious diseases, we will see a rise in new cases that are being undetected and a delay in treatment. And these are very important for people working with other emergent diseases to keep in mind that we will see that spike. It is unavoidable, I think, and we need to find ways to start and plan how to embrace it, control it, and bring it into lower levels again. Another very important point is vaccinations, because during the time where many people stayed home, a lot of kids missed their very crucial vaccines, that they would take regularly at their pediatrician's clinic. So also, I think there needs to be planning to see who skipped all these different vaccines and try and give those, because we will see surges in diseases that we have controlled for many years. And now, because many of them are missing those vaccine regimens, they might come back again to create, health issues.
Thank you for that. And you also, Önder Hocam, did you have something to add?
No, I agree. I agree with Issa that, we also had to postpone some of our other emergencies. Sometimes I'm giving priority for the COVID-19. But slowly, step by step, we will turn back, to all our old conventional problems again.
Wow. Let's hope so. Let's hope we have no problems someday. Hopefully. But, yeah, and Issa, you mentioned intranasal vaccination platforms. And are there any current studies towards developing one, or is it just something that you foresee?
Yeah, as far as I know, there are, but they were, and that's a while back because I have not been following up on the subject. They were in phase 1 trials. As I mentioned, they are mostly compatible with adenoviral vector platforms. I'm curious to see what would be the outcome with RNA vaccines like Pfizer, BioNTech, and Moderna, whether they'll be able to inject those RNAs into the nasal cavity. I don't think that they know for sure. There will be trials. I don't know if there are. Maybe Professor Önder knows more than I do. If there are any ongoing trials with RNA intranasal vaccines, I don't know, Professor Önder, if you have an idea.
There are some nasal vaccines. I think these are quite promising, but unfortunately there is a problem nowadays because it is very difficult to find the subjects for these studies, vaccine studies. Maybe we need some more time to pass, maybe 6 months or a year to study these vaccine candidates. But there are nasal vaccines which are good, and it will be easier to apply, easier to use. But also we were one of the centers that doing that kind of research, but we have difficulty in finding subjects because if the individuals who want to get vaccines, they already get vaccinated with some other options. Because ethically you cannot say don't get vaccinated and then I will make such a trial, etc. So therefore, that's the problem.
I think it's very much worth now looking towards countries where we have lower vaccination rates. I mean, you've mentioned the Southern Hemisphere really is missed, especially the African continent. It's really at very low levels of vaccines. And this is a time where we have to really boost the vaccination and also introduce those trials with the intranasal in subjects that are unvaccinated. Another strategy would be to use them as boosters, and also that's not something, that's not a bad idea. See those that have already been vaccinated in their arm and try and use an intranasal as a booster. I think that could be another way that you can do that at your institution or in any other place.
Yeah, I agree.
And I believe we have one more question. Okay, no.
Or I have a question for Professor Önder about treatment I received yesterday, actually, from one of the participants. He was asked about ivermectin. There was this big story about the antiparasitic drug that we use for worms, and ivermectin. From what I know, it has not shown real success, but I would like to hear more from you. What do you think? Do you agree that this is not a drug of choice, or does it have a chance?
First of all, I should say it is not a drug of choice, I can say. But there was a paper just released a couple months ago, showing the benefit of the ivermectin for COVID-19. But then it was understood that it was again early bird kind of paper, and it was retracted. So therefore, in many guidelines, including the European or American guidelines, there is no space for the use of the ivermectin, like favipiravir, which is very common in Turkey, for instance, and it is freely distributed to the people who have COVID SARS-CoV-2 positives. There is no any word or any support for favipiravir in major guidelines like American guidelines or European guidelines. Ivermectin has the same fate with favipiravir. We have such drugs, yes, but in like that is done for favipiravir in Turkey. Brazil distributes freely the ivermectin to the people. Actually, the politicians in every country, in many of the countries, prefer to give drug because saying to the people that this is the drug is an important and strong argument. As you may remember, that Trump did this a year ago, promoted hydroxychloroquine. Then we understood that hydroxychloroquine has no effect, and it was just again, stopped by many countries.
Yeah, so I think it's a word of caution here, I guess, that we're both sending out to all of you here is let's not jump very quickly to any drug that has been, promoted, especially if it's a recent finding and someone is just one party or another is just talking about it. Hydroxychloroquine, a drug used for malaria, was promoted for a while. Now we know it's not effective. Zithromax, the antibiotic for a while, you say I have COVID, they give you this Zithromax, and now ivermectin. So a big word of caution on repurposed drugs that have been used in the market for other purposes, and now they say, oh, they're good for COVID. Please consult with your physician. Be very careful before you take those drugs.
So now I have another question in the chat box. Jessica would like to know if intranasal vaccines are common and whether they are being used for other diseases and whether they are truly established.
Yeah, they are. I mean, if I may, we have very established flu intranasal vaccines. They're usually not killed. They're usually attenuated. So the virus is still alive, but weak. And it's working very well. It has indications, of course, because if your immune system is down, then it's not recommended that you take this kind of vaccine. But then if we create it in a different way, where the virus is not alive, or we're just using a piece of that virus or whatever, then that should be safe to use on certain platforms. Professor Önder, I don't know what you have to do.
Yeah, I agree. In influenza, in some countries, there is that form, but in some countries, there is no. I mean, it is not that accepted, but more or less, they are useful and could be used, beneficial, using that intranasal vaccines, although not as wide as the subcutaneous or intramuscular forms or parenteral forms.
Thank you for that. And finally, how should we deal with anti-vaccination supporters, anti-vaxxers? Yeah, how do we talk to them?
Professor Önder, please.
Okay, thank you. In fact, these anti-vaxxers are also creating some heroes for the science as well. For instance, one of well-known hero is Peter Hotez from United States, from Texas, and he is fighting against. He's creating lots of arguments. These are interesting for me philosophically because these are also the arguments for defending the science. So not only in the vaccination, but also in many other things, we have to defend science, especially the people who have a, education, science education, etc. We should also think about how we can defend this in many aspects, because it reflects and disseminates to many areas of our life, to our lifestyle. It affects our lifestyle, not only in the vaccine issue, but also in climate change, for instance, which is another important problem, or traffic, or living conditions in big cities, etc. That we live all these many multi-layered problems in the world. This is a very important problem. So therefore, vaccines, anti-vaxxers, and our struggle against anti-vaxxers is a typical interesting example how we can defend the better life, better living conditions for all. Therefore, it is important, but it's not easy because it is multi-layered and there is no pragmatic single solution. But we should be, active, dynamic, and never give up for talking about the vaccines or the science and the products of science.
Yeah, if I may add a word, I agree with you. I think this has been an ongoing battle, and it will always remain to be an ongoing battle. We should not, absolutely, scientists should keep, fighting with facts, with science, arguing for the importance of vaccinations. I mean, we have certain areas, for example, in the US that went anti-vax, strongly, and we've seen cases of polio coming back in those places, and that is scary. You know, when you talk about certain diseases which we thought we put behind of us that became history, and now we're seeing them re-emerging, that is a warning sign where we have to say we have to be careful. The human mind is somehow in a way designed to be inclined towards superstition, to be inclined towards conspiracy theories. So they have very fertile grounds to work on, and usually not using, you know, solid data. So it's so easy to just, you know, create this fear or this conspiracy theory towards something. And then in the end, I think what's important is put the facts on the table. Say, okay, we've got these number of people who got vaccinated, this number of people who did not get vaccinated. Let's see how many of those got sick. Let's see how many of those went into the hospital. Let's see how many went to the ICU. Let's see how many died. And then, you know, show without any doubt that putting on the seatbelt, like Professor Önder said, is absolutely essential and important. You know, if you want to risk your life, you know, it's not just your choice. You know, because if you put the seatbelt, yes, it's your life. But if you're not getting vaccinated, it's your life and the lives of people around you that's in the stake.
Thank you for that. So if there are no other final questions, we would like to end our talk here. And I'd like to thank both our speakers, Dr. Ergönül and Dr. Abu-Dayyeh. And Dr. Ergönül is still at the hospital right now. He needs to go home. So, thank you again, everyone, for joining us. And we hope to see you at our next event, which is on November 18. And we'll be featuring Serhan Sözer, who has founded a renewable energy company in Turkey, and it will be about the climate crisis. So see you then.
Thank you very much. Bye-bye.
Thank you.
Thank you very much. Thank you, Ur, and thank you to the MAA chapter for this opportunity.
Thank you. Thanks
you,
for
Turkey.
joining. Thank you so much for your time.
Bye-bye.
Bye, everyone.